Okay, let's try again. So, happy Wednesday afternoon. Welcome to our optional live online session. And what we're going to be doing today is that we're going to really spend most of our time looking at the weekly chapter. We'll start talking a little bit about cartilages, but spend most of our time really talking about the bone tissue and role of the skeletal system. I want to make sure that I spend a little bit of time checking in. We'll also address briefly these live online sessions. I want to mention the weekly homework assignments that we have. We won't spend too much time talking about the exam and practical yet. Those are taking place next week, but I know that I always have a few students who are nervous and anxious to understand more about those. So we'll circle back to them later on next week, but I'll just mention very briefly about them. Bulk of the time is spent on looking at the chapter 7, and if we have time, we'll even revisit the homework that's related to the weekly assignments. As always, even if you are joining me through a recording of this session, don't forget that I am very much here available for live interaction. You can send me a message through our Canvas discussions tool, or you can join me during my office hours or during these live online sessions, or we can even find a time and day that works for both of us to get together virtually. Like I said, it's important for me to know how you are doing, and as always, let me know if you have thoughts, concerns, questions, celebrations, whatever. So let me fix this slide real quickly. I don't want to make a start of recording all over again, but I do want to make sure that I'm showing you the right information on the screen. So let's share my screen all over again. And we should be back where we were earlier on. So I'll keep offering these live online sessions for now on Wednesday afternoon and on Friday morning. I am eyeing on changing potentially a little bit of the day and time, and maybe dropping one of the weekly sessions. But as always, I do offer the recordings available for you as well. This week we're working on chapter 7, so I have chapter 7 quiz and chapter 7 practice anatomy assignment, both due at the end of the week, at the end of our Sunday. I believe it's 22nd. So kind of more back to the familiar structure of homework from what we had last week. Next week, we will be taking our first exam and first practical. And at that time, I will review with you in great detail what to expect, what to anticipate, but I want to make sure that you know that it is covering the chapters 1, 6, and 7. So those kind of review chapters that we did about the basics, chemistry, basic cell structure, basic tissues, and genetics a little bit. You've already been tested on those on your previous courses, so we won't spend too much time on those, but I do want to make sure that we take our test on chapters 1, 6, and 7. At the beginning of next week, I will be providing you thoroughly information, what to expect with the testing. Those are tests that you'll take online on Canvas course, and you will be certainly well prepared for them if you are constantly working through your quizzes and practice anatomy weekly homework assignments. They're really the key for those. But without a further ado, let's have a look of a little bit of the skeletal system. What's interesting, I think, is that human skeleton really and bone start as cartilage, and during the process of ossification, that cartilage then is during early development replaced by bone tissue. There are some areas that still remain cartilaginous where we're requiring a significant amount of flexibility. You can see on the screen an X-ray of developing child, and you'll see that the bones are only partially ossified on that. So that also is a tool that we sometimes use to age the developing baby. In terms of the cartilages, there's really three main types of cartilages that we find in the body. Hyaline cartilage is really the most common type, contains a lot of collagen fibers, and we find hyaline cartilage in most joints at our costal cartilage, so where the ribs join to the sternum, and in our respiratory system, including larynx and tracheal tree, respiratory tree, and also as our nose cartilage. So the tip of the nose is made of hyaline cartilage. Elastic cartilage, much more elastic fiber present there. Really two places that I would highlight from there are our external ear, and then the epiglottis, that little flap-like structure at your voice box region, or a little bit above that. Finally, in terms of the fiber cartilage, these are made of very thick collagen fibers. We'll find those, for example, at the menisci of the knee as intervertebral discs, and also at the pubic symphysis, where the hip bones are coming together. That's an interesting structure because we do end up seeing that actually separates during the childbirth. But now that we've had a look of cartilages, let's shift our focus on talking about the bone in general. Bone provides our body the scaffolding, the support, where a lot of other stuff is hanged on. If we didn't really have a skeletal system, we would be this kind of a blob on the floor that would have a hard time performing the functions that we have assigned for the body. Your skeleton also protects many important structures. You can think of our skull that protects our brain. You can think of our rib cage that protects many vital organs like your heart, your lungs. We see even protection around the pelvis area for structures within this space. So, and obviously I should mention our spinal cord protected by our vertebral column. So bones very much provide these protective structures. We need bones also to generate movements. We'll be moving on soon to talk about muscles and muscular system, but I wanted to start with the skeletal system because muscles attach to bones. Typically, muscles attach on two different bones and they cross a joint, and by either tensing or relaxing, we're able to then generate these movements. But that's not all that bones do. Bones are a great location for storing things like calcium, phosphates. We can store and release them as needed in the body as well. The process of hematopoiesis, production of the blood cells, takes place within the long bones, especially at the bone marrow. The red bone marrow is super important for that. So that's why we sometimes see things like bone marrow transplants for those patients who are unable to produce the blood cells themselves. We'll also see that bones, especially the yellow bone marrow, serves as a storage place for fat and fatty tissue as well. And we'll see the role of the skeleton also in our endocrine system regulation, so hormone production and navigating that space. So a lot more going on with the skeleton than many of us probably initially intuitively would think. We can classify bones based on their location into two main groups. So we're going to see axial skeleton that forms the long axis of the body, and that includes the bones that form your skull, vertebral column, and rib cage, whereas appendicular skeleton really is the bones of the upper and lower limbs. Pay attention to these transition zones. So on the upper limb, your scapula, so your shoulder blade, and your clavicle, so collarbone, are part of the appendicular skeleton. On the lower limb, your hip bones are part of your appendicular skeleton. So just make sure that you know what's appendicular, what's axial. We can also classify bones based on their shapes into long bones. I think that upper limbs have many prominent humerus, same for lower limbs, very prominent long bones that we're seeing, whether it's a humerus or femur or ulna radius, tibia fibula. They're very good characteristic examples of long bones in our body. Short bones are kind of more of a cube shaped, like I think our carpal bones and bones of the ankle are particularly good examples of those. Then we have flat bones. I think that again, your chest bone, would be a good example. Bones that form your skull would be particularly good examples. And then the irregular bones is kind of a catch-all group for all other bones that don't fit into other categories. I think that our vertebrae are particularly good examples of those. We can also look at the bone, whether the structure is compact or spongy. Compact bone is typically found as the outer layer of many bones, and spongy bone is this kind of more like sponge-like matrix, honeycomb-like matrix inside many bones. That helps us to reduce a little bit of the weight of the skeleton, still providing structural support though. We can also look at the bones when we look at a long bone, different portions of that. So we have epiphyses are the ends. So we're going to have a proximal epiphysis and distal epiphysis. And then the main part of the long bone is the diaphysis. We can see a few other structures on this, articular cartilages at the end of the bones, preventing the bone rubbing from against bone, especially at the joints. We see the epiphyseal plate or epiphyseal line. That's the site where the length growth of the bone has taken place. Periosteum, connective tissue layer around the bone, and then the bone cavity, where we see a lot more structures. We'll see, for example, our bone marrow there. I mentioned the periosteum as the connective tissue layer around the bone, and there is a rich blood supply also to the bone. So remember, bone is very much of a living structure, so it needs that constant supply of nutrients, oxygen, energy, removal of waste products, and so on. In a couple of weeks, when we look more into the bones, we'll definitely see more about the different bone markings. We'll see really that we can talk about projections, we can talk about joint regions, we can talk about depressions or openings on the bone surface. And that allows us to formulate that kind of common language. So really the best way to learn this is by looking at the individual bones. Like I mentioned, bone is very much a living tissue, so we see really three main bone cell types. We have osteoblasts that are kind of immature new bone cells producing new bone. How they do it is actually building the bone matrix around themselves. So I often describe to my students that osteoblasts almost get trapped inside their own bone that they produce. And as they do so, they become now osteocytes, which are mature adult bone cells. These still osteocytes do have these arms that extend to other parts of the bone, but they're kind of trapped inside the bone that they've secreted around them. And then we have osteoclasts that are breaking down bone, releasing material so we can build new bone. So bone is constantly being broken down and rebuilt. So that's why really taking care of your bone health is important, that we can strengthen our bones based on the stressors that they're exposed. Here we see a microscopic view of the compact bone. You'll see that we very much have this rounded-like structure around a central canal. We'll see openings here and there, and this lamella-like structure around that central channel. I'll let you study that in more detail independently from textbook. A single bone unit around that opening is an osteon. And then, like I said, we see rich blood supply, nerve supply, lymphatic supply to the bone tissue as well. I've already referred to this a little bit, that this process of bone being broken down and built up allows us to change the bone, strengthen the structure based on the physiological stressors that they're exposed. So bone is very much a living material, constantly being broken down and built up again. In terms of the formation of the bone, there's two types of ossification, endochondral and intramembranous ossification, which are definitely worth of looking from your study materials. When we talk about fractures of the bones, we're talking about breaking the line of continuity of a bone. And there's many different kinds of fractures. We can have fractures that are non-displaced, so the bone ends remain against each other, or they might be displaced. Obviously, for healing those displaced ones, we need to bring them back in lining before we let the bone to start to heal so that it doesn't heal in a wrong shape. The break can be a complete or incomplete one, so whether it's completely throughout the bone cracked or only part of the way. We can also talk about fractures, whether they're closed, so the broken bones remain inside the skin, or whether it's an open fracture where we see those bones poking out of through the skin. There are many other types of fracture classification systems. I'll mention the green stick one here. That's like when you take a young branch of a tree and try to break it, it kind of doesn't just snap. It has these fibers that come out, but it's very flexible. And this is often what we see with younger patients' bones as well, that it doesn't really fully break all the way through, might break on one side, but other side just merely bends. So I'll let you look into those more as well. Osteoporosis is a clinical condition that I've highlighted here, is when we have insufficient bone density. So again, this is something that impacts especially females post-menopause. So ensuring that we build that strong skeleton before that, it is very much of a worthwhile activity for us. We can treat osteoporosis to a certain amount, but really I would encourage patients always to build that strong skeleton rather than treating when issues arise. So getting sufficient amount of calcium, vitamin D, putting some stress on your bones, but not so much that it damages them. And obviously in case of the females and postmenopausal females, that is one of the reasons why some opt for hormone replacement therapy as well, slowing down the bone loss. So that brings us to end here what I had here. I know it's a little bit of a quicker review. What I wanted to do next was to show you what to expect from the homeworks again. So let me see if I can open them on my end. And we'll have a look of the chapter 7 homework a little bit together. Let me pull up our weekly material. And let's share the screen. And at this point, you should be able to see my screen where I have the quiz 7. I'll show a couple of examples of what to expect. We'll see that it's going to be 15 questions, 10 points in total. We have, for example, complete a sentence questions at the beginning where you'll choose from the drop-down menu the most correct answer to make these sentences make sense. So we see, for example, on the first ones, the bones of the skeleton provide structure to the body and serve as support to hold up the body and maintain proper positioning of some organs. We're also seeing that the skull, pelvis, ribs, vertebral column, and sternum provide protection to many delicate organs of the body by encasing them in hard and shell-like or gauge structures. So you'll use this as kind of logic to complete this sentence so that they make sense. On this first question, I also do have some simple multiple choice questions. We're seeing which of the following best describes osseous tissue. This is a connective tissue with hardened matrix that makes up the bone. We'll see that osseous tissue matrix is composed of what? And it's composed of calcium phosphate. That would be the correct answer there. We do have also some of the familiar drag and drop questions. So we're here classifying what are flat bones, irregular bones, short bones, and long bones. So a good example of a flat bone would be our sternum. The flat might be misleading a little bit. They're slightly curved bones often. Irregular bones, I think sacrum is a particularly good one. There are bones that are kind of oddly shaped. Often found in axial skeleton. Short bones, scaphoid is a good example of that. In these, the length and width are similar in proportion and they allow small degrees of motion, usually in 2 degrees of freedom. Long bones such as femur would be a good example mentioned here. They serve as levelers for body movements, and the length and width proportions are greatly different. So again, very similar question to what you've done before. I also have somewhere you will be typing in your answers. So the interior of flat bones is composed of spongy bone, like we just saw. Let's have a look at one more here. You're being asked about the bone dissolving cells on bone surfaces, and these were our osteoclasts. They were responsible for breaking down bone. So I hope that that helps you to kind of anticipate what you might expect in terms of the homework on this chapter. We can also have a look of the practice anatomy together a little bit. Let me share that screen with you. And here again, we are looking at bones and classifying them. We're seeing good examples of flat bones, scapula, sternum, and cranium. Irregular bones, sphenoid is a particularly good one. Also vertebrae fall into this category like we saw. Short bones, capitate bone, talus, good examples of that. And for the long bones, ulna, radius, and femur are the ones from this list that would belong there. So a chance for you to really look at these bones. Here we're looking at the anatomical parts of a long bone. We're seeing different parts. Rather interestingly, the articular cartilage at the ends, preventing bones from rubbing against each other. We're seeing some red bone marrow, and we're seeing the epiphyseal line. That's the growth plate. Once it has fully matured, we're seeing the marrow cavity where we see the bone marrow. We're seeing yellow bone marrow there. We're seeing the foramen for nutrients. So there's a lot of openings in the bones to carry materials in. And we're also seeing the periosteum, the connective tissue layer around the bone. We'll see many other nice examples as we work through the materials, continuing, for example, with those long bones, but we can also look at the stress that the bones are under, as in this picture, and that allows us also to separate between compact and spongy bone, for example, here. Good questions, good learning opportunity. And let's have a look at one more here. Here we're seeing the process of fracture healing, and we're organizing the steps into correct order. Your textbook does a rather good job of going through those. So where does that take us? That takes us to the end of our session today. And again, I'm going to share my screen just for the sake of completedness. Provided I'm able to get there. Guess we're not. I'll just share it this way then. But that really brings us to the end of our time together today. I think we've had a bit of a quick look of the chapter content. This chapter is really orienting us for what's to come when we start looking at the individual bones. This chapter has been really kind of organizing us there. I hope you are a little bit more at rest what to expect with the exam next week. And just make sure you keep doing your good work, collecting those points. That is really the secret to a success on these online classes. And at this point, I will wrap up our time together. And I appreciate each and every one of you for your good work. Keep doing that, keep collecting those points, and I'll see you at the next chapter if you're not joining me to discussion forums or on immediate interactions. Until then, thank you and bye.